All right, good day, everybody. This is Jason Straight with Pass Cloud Virtual Group. Our presentation today is SSDT, Docker, and Azure DevOps, and our presenter is Dan Mallott. Hopefully I got that right. I forgot to verify that with you right before we got started here. But before we get off with the presentation, I'm going to go through just a few announcements. Okay, go to the next slide. All right, there we go. So the first thing is that we've got a number of sessions coming up. So I'm keeping the calendar full. We've got 19 sessions scheduled over the next few months. The items in orange are the ones that were just added this past week. So we've got 3 more that are on the schedule. I think I got like 5 more people that we're just working on getting dates on. So we've got lots of great sessions coming up. Really encourage everyone to go out there, check out the sessions that are there and find the ones that align to you. You know, we've got sessions now going all the way out to the end of October. If you're interested in presenting, it's a cool thing about the calendar. It just keeps going on and on, so there's always room for more and new presenters. If you are interested, please email me at cloud@pass.org, or if you'd like, you can go out and fill out the form that's on the cloud.pass.org website. Just click on the Cloud Virtual Group Call for Presenters, and that'll bring you to a Google form. Fill that in, and we'll get things situated for you. And when it comes to presenters, I'm looking for pretty much anyone across the board that's got something about data in the cloud that they want to talk about. This fall is PASS Summit 2019. I believe it's the 21st PASS Summit. New for this year is Learning Pathways. Learning Pathways are basically the curated 75-minute sessions where it goes from the introduction early in the week to advanced topics later in the week, where you can really dig in and learn something new at PASS and really, amp up that learning experience. If you are interested in finding out more about the learning pathways that are available, you can go out to the PASS Summit 2019 website and just click on the Learning Pathways page. If you have yet to register for PASS Summit and you don't really feel like paying full price, we have a deal for you. You can get a discount on your registration by just typing in the VGDIS FKDQ, and if you do that, you'll get $150 US off of your registration. This virtual group is part of a number of virtual groups that are out there. Some of them are more language focused, so there's a global Spanish, global Chinese. Some of them are job role focused, like data architecture, and others focus on different aspects of your career, like professional development or women in technology. So it's a great way to go out and find more and learn more about data platforms on the Microsoft architecture. Throughout the session, you may have a few questions. I think I actually may with today's presentation. So I encourage you, if you do have a question, to go out to the questions panel within the GoToMeeting interface. Type in your question there, and then at the end of the session, we'll go through those questions and give Dan a chance to answer those. And so this time, those are all the announcements that we have for this session. Again, the name of the title of our session is SSDT, Docker, and Azure DevOps, and our presenter is Dan. So let me make you a presenter. All right, there you go.
And thanks, Jason. My Mac was just going to take a minute here to catch up. Let me know when my screen is showing.
Yeah, I can see the PowerPoint now.
All right, perfect. So as Jason mentioned, my name is Dan Mallott. I am a principal with West Monroe Partners. We're a full-service business and technology consulting firm based out of Chicago. And this talk is SSDT, Docker, and Azure DevOps, how to make your database builds a first-class CI/CD citizen. So what's on deck? Why are we here? And not in the metaphysical, existential sort of sense, but why are we having this talk? Why is this a topic? We'll look at the tools we'll use for this. I'll cover unit testing, and yes, in a database, it is possible. It may take changing the way you do things a bit, but that's okay. And then towards the end, we'll look at Azure DevOps builds, pulling it all together, the build, the testing, and the deployment. And then we'll leave plenty of time for questions. So I know that this is a topic that is relatively new and maybe controversial depending on your own practices. So feel free to keep those questions coming in, and we'll address those at the end. All right, so why do we want to do this anyway, right? All the time we talk about databases, and particularly our DDL, and it's special, right? The challenges we have in deploying database changes are, there are a lot. Whether it's, well, how do we roll back safely? How do we deal with data that's in the database? What if we're changing a column type, changing a column width, changing a column name? All of those things are considerations, and it's more difficult than maybe our friends on the application development side have it. So I'm going to start with some definitions. So DevOps, according to the source of all knowledge on the internet, Wikipedia, is a set of software development processes that combine software development and information technology operations to shorten the system's development lifecycle while delivering features, fixes, and updates frequently in close alignment with business objectives. Okay, so what does this actually mean? What it means is that by automating our build and release pipelines, along with adding some rigorous testing, we can turn around code changes from the identification of a feature or a bug into production in a much faster and more automated way than we could previously. So the idea is that we no longer have the developer sitting at his machine, pressing the build button, and then copying his build artifact out to a server, and hopefully he didn't make a mistake. And instead we're using tooling to automate that process and make sure that everything is repeatable, and we don't have to concern ourselves with whether or not things are going to fall over because someone put the wrong config file in. And I can say I've never actually done that, I promise. Continuous integration. So continuous integration is integrating into a common branch frequently, building the code and running automated unit tests to ensure the changes are valid. So the idea with this is every time we check a change into a specified branch in source control, whether that's a develop branch, a master branch, or whatever you happen to call it, we're going to automatically build those changes, run unit tests, maybe run some integration tests as well, and make sure that all the changes that we just put in didn't all of a sudden cause the system to break, right? And this is an extra step that allows us to take any of our point-in-time code commits and deploy it and know that we're going to have a system that is working to the best of our knowledge. The other side of that is continuous delivery. So continuous delivery is the automated release process that allows push-button release of those continuous integration artifacts. Continuous delivery is a really, really good idea in your dev and QA environments. It is something to think about a little bit more thoroughly when you're talking about a UAT or a prod environment, right? So that's why we say it's a push-button release, not an automatic release, because some environments we may want to just push the changes into, and it's fine, we don't worry about it. But when we're talking about an environment where our customers are actually going to be consuming our application, we want to be a little bit more rigorous and careful about releasing those changes. I'm a little stuck there. So why do we want to use a CI/CD process with our data definition language? So this is the language that specifies the shape of your database, right? So the simple answer is DDL is a part of your code base, just like the application code, whether it's C# or Java or what have you. But there's some additional benefits there, right? So if you're practicing CI/CD in conjunction with storing DDL and source control, your application developers are going to be able to see the changes and consume the changes and participate in the process. So it helps to break down some of those walls of like, well, somebody over there in the database group changed a field and I didn't know about it, now the application is broken. Well, but it's in source control, so you knew, right? You're also going to share a common development, build, and deployment mechanism with your application developers. The benefit there is we don't necessarily want to have 4 different processes for deploying an application. Ideally, a single application has a single deployment process, and we don't have to go, oh, well, did you do this step over here that's not part of the process, or that's in a separate process, because unless you did that step, I can't do my next step on our side. Along with that, you can say definitively, this is the version of the code that was deployed. Because you have a build pipeline that creates an artifact that's time-stamped and tracked, and that artifact was deployed, you say, okay, this is what was deployed. We know exactly what was deployed in production. Or like, hey, we know that in the case of maybe a multi-tenanted environment where you have different versions of the code deployed for different tenants, hey, version X is breaking. Okay, well, I can pull version X from my source control and handle everything locally. And then the last thing is applying a compilation or build process to your DDL can help identify issues such as misspellings or missing objects. The misspelling there is intentional. So a lot of times when we're just working through Management Studio and adding objects, I for one take great pride in my spelling, but there are certain words that I cannot type to save my life. So having to check me and make sure that I didn't misspell is very useful. And I have a certain degree of confidence that just through the build or compilation process that all of my DDL is going to fit together, and I'm not all of a sudden going to run a stored procedure and go object not found, which I think we've probably all run into. So with that baseline, let's talk a little bit about the tool set that I'm using in this talk today to demonstrate how we can get this going. So SSDT, SQL Server Data Tools. It's a component of Visual Studio. It allows you to easily organize your code, DDL code, tables, views, store procedures, almost every other component in SQL Server. And then it builds it into a deployable package known as a DAC pack. In Visual Studio 2017 and 2019, the basic functionality is built in, but SSAS, SSIS, and SSRS require an additional plugin and spell check. So why would you use SSDT, right? Why couldn't we just store our scripts in a folder and yeah, it's checked into source control and it's fine? So SSDT is an incredibly source control friendly way of storing the shape of your database. You can reverse engineer, you can schema compare. For those of you who are familiar with Redgate's schema compare tool, there's very similar functionality built into Visual Studio. Visual Studio is also the same tool used by your developers. If you have SSAS, SSIS, or SSRS running in your environment already, you're already using SSDT. You might just not have known that it was called that. As I mentioned before, the build artifact is easily deployable across a wide variety of platforms. Basically using PowerShell or using an Azure DevOps task. We'll see that a little bit later. You can target multiple versions of SQL Server. So if we think back to our multi-tenant example earlier where you have multiple versions of the code running, you may also have multiple database versions, right? And so, setting aside the administrative nightmare for a second, by being able to target multiple versions of SQL Server, we don't have to keep multiple copies of the code that's going to work. Or we don't have to remember like, oh, right, temporal tables weren't available before 2016, so I better not deploy that to my 2012 R2 instance. And then lastly, as I mentioned before, SSDT performs syntax checking while you develop. So that really allows you to catch issues up front. I'm going to jump out of the presentation real quick. And we'll go over here. And so this is what SSDT looks like in Visual Studio. So you have what I've called my referee scheduling system.database, then referee scheduling system.database.test, which we'll talk about in a minute. And what you have in here is, the way I choose to organize it is by schema and then by object type. This happens to sort of closely mirror what the reverse engineer functionality gives you. But really, it's up to you, however you feel like handling it. And then when you look in to some of the code files, for some of them you get this sort of nice design surface, right? So this looks kind of familiar based on what we have in Management Studio. But you also have the DDL right below, and you can scroll and you can edit it. You can see, like, I've done some things where, like, okay, yeah, there's temporal tables involved with this. I use some masking functions as well. But also you'll notice the Visual Studio picks up on other objects that are defined elsewhere in my code that reference this table. So for example, it says PK referee. Okay, well, if I look in my keys, hey, there it is, PK referee, add constraint, blah, 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 right? And so this works across all of the types. So you can see we have, some foreign keys that pop up. If we look at stored procedures, so I've got my stored procedure, and this doesn't give you a design surface, but it does give you syntax checking. So if I did that, all of a sudden we're going to get, I don't know what that is. All right, Docker. What is Docker? So Docker is a word that you guys have probably heard a lot about. Maybe some of you are using it in your environments for your applications. Maybe some of you have even played around with the SQL Server Docker container. But basically, Docker is a tool that allows the creation and deployment of containers. And containers allow you to only host the parts of the OS that are absolutely necessary for running an application along with that application. So essentially, you're getting the flexibility of virtual machines without the large overhead of having to spin up a virtual machine with a full copy of Windows Server and all this management overhead. Instead, you just spin up a container. Containerization allows applications to scale really quickly and flexibly. You can also, depending on how your application is architected, upgrade parts of the application without taking the whole thing down. They're generally lighter weight and require fewer resources. And because they're easy to bring up and down, allowing for conservation of server or developer machine resources, it's a lot easier to entire large environment on your machine. So for example, obviously I'm on a Mac. I run Parallels so that I can run Visual Studio. No commentary on Visual Studio for Mac there. It just doesn't do what I need it to do. But I run SQL Server for my development in a Docker container on the Mac side of my computer, and that allows me to bring it up and down as I need so that SQL Server isn't always running in the background, draining my battery, taking resources, or so that I don't have to bring up my Parallels environment just to do some work in SQL Server. I can just use the Docker container and use Azure Data Studio on my Mac side without ever thinking about Windows. Which brings up that containers are portable, right? So the container you run on your desktop can easily be run in AWS, Azure, Mac, PC, Linux, anywhere the Docker runtime is available. And as I mentioned before, Microsoft makes SQL Server available in a Docker container, so it simplifies development, allows you to isolate each database in development, if you so desire. All right, Azure DevOps. So we're going to touch on this briefly, and then I'll get much more deep into it later. So Azure DevOps is Microsoft's build deployment automation tool. It also offers source control and work capabilities, work tracking capabilities. So if you think about it, it's really sort of the unification of Team Foundation Server and Visual Studio Team Services, which were previously unified in what was called Visual Studio Online, which is now Azure DevOps. It is offered in on-premise and cloud versions. Microsoft very strongly prefers you use the cloud version because they release features to it much quicker, and it's somewhat more standardized, I guess. Azure DevOps integrates into the Microsoft ecosystem really, really well. So there's native build tasks for C#, F#, ASP.NET MVC, SQL Server, pretty much anything you can think of. But they also bring in non-Microsoft Stack build components such as Java or Docker or things like that. And then it gives you a range of options for deployment. It's pretty handy this way. Obviously, the easiest thing is to go, Azure DevOps to Azure. But you can also deploy to on-premise. You can use your own build server if you want, even with the cloud version. And that's pretty compelling from a toolset perspective. Unit testing. So application developers are very familiar with the concept of unit testing. The idea is you take a small component of code and test it in isolation, and then when you put all of the components together, they should all work together. So why do we want to do this in our database, right? The thing is, almost all of us have some sort of business logic in our database. Whether that's in a stored procedure or some sort of unique constraint or some sort of like default or some sort of check constraint where it's like, okay, well, our gender field can only be, this set of values, or, we aren't going to take anybody who was born before 2001 or born after 2001. And the important thing there is, the other thing is, even if your stored procedures or functions are just getting data or adding data, if you just have CRUD, those stored procedures and functions may stop working or may work differently if you change DDL elsewhere in the system. Now, using SSDT helps us with this because you'll get a build warning, but doing testing is a nice backstop there. So the tSQLt unit testing framework, available at that URL, can help detect regressions in your code in the database. It was built from the ground up in SQL Server to help do SQL Server unit tests. There are a couple of caveats there. One, it requires the CLR to be available. So that may be a no-go in your environment depending on security. The other thing to be aware of is that it does look for you to write your code a specific way. It's somewhat opinionated. There are ways for it to mock tables and things like that. But if you have a 500-line stored procedure that does 4 things, you might find unit testing that difficult. And personally, I would argue that you might want to consider refactoring that out a bit into a parent stored procedure and for sub-stored procedures or something like that. But just be aware that that's a limitation. So we're just going to pop out real quick, and I'm going to hop back over to Visual Studio. We'll quick check on time as well. And we'll take a look at what the tests do. So the first thing to know here is that tSQLt itself comes with a bunch of stored procedures and functions that help you to actually write tests. And so for any of you who are familiar with unit testing in general, you're going to find that, things like assert are very familiar. There are also all these private ones, and then some runs, table of text, which we'll talk about later, and some other stored procedures that help there. The big thing to look at here is when we look at a test, and so I have some lookup tables in my main project, and I basically, for the purposes of this demonstration, am writing some unit tests that don't really prove us much. So, for example, my sport type table has a post-deploy script that loads it up with one sport type. In this case, ice hockey, because that's what I referee. So in my stored procedure that I'm using to test it via tSQLt, I declare some things, and then I'm just selecting the count from the sport type. And if it doesn't match what I expected, it'll throw a message and fail the test. Likewise, the stored procedure we looked at earlier, again, has a unit test that says this should return a table, which is just another way of making sure that it returns what that one row that I expected. Again, this is a little bit more complicated. I have an actual and an expected. I've set up my expected, this is what should be in there. I inserted my actual, the results of the stored procedure, and then we do our assert. And what the output of this looks like, we run it in Azure Data Studio, is okay. So 2 rows affected, test execution summary. I have 2 unit tests. So this unit test, success, gives me how long it took. This unit test also success. And then I get a summary. 2 test cases executed, 2 succeeded, 0 failed, 0 errored. So this is very useful from a unit testing perspective. We'll pop back over into here. All right, so Azure DevOps builds. This is where we're going to put this all together. And I will pop back out and show you my build pipeline. Which Firefox is having some issues with, apparently. All right, so the idea is we have our database project. We have some unit tests. We need a way to run those unit tests as part of our build pipeline, but we don't want to leave a SQL Server running, and we probably want to start from a clean slate every time, or at least a known good state, right? So that might be a database backup. So if we jump into this build pipeline, what we're going to see is, so at the start, I get my sources, right? And this is available out on my GitHub. And then we run into our actual build database task. So we start by building the database, build the tests separately. And I know I haven't talked about why that is, but I'll get there in a minute. And then using the Azure CLI and Azure containers, what I'm doing is I'm creating a resource, on the fly, I'm creating a resource group for my database container, creating a test container. So this is a container using the Microsoft SQL Server Linux latest image, using latest because this isn't something that's been deployed out, and at some point in the next few months I'll change it to 2019. But basically just to create the latest SQL Server. And then using our Azure SQL database deployment task, I'm deploying the main database to our SQL server that we created. So, and you'll notice this matches back here what we did for the DNS name, Test Referee Scheduling System Database. So we're deploying this out. Please don't hack my password. Then we deploy the test on top of it. Now, one thing that I should mention before we go too much further is when I split the projects, I made them components of the same database. So when I deploy these DAC packs, they won't overwrite each other, which is kind of important. It wouldn't make much sense if you overwrote your main database with your test database. Then we run the tests. So again, I'm sort of abusing the Azure SQL database deployment task's ability to run arbitrary SQL to run our exec tSQLt run all. Could also do this with PowerShell if you wanted, which is what I had to do in order to get the results out because of tSQLt things. We get the results out in JUnit format. JUnit format is a common unit test result format that Azure DevOps uses behind the scenes to pull in all of the unit test results for everything. Go ahead and publish those into our build pipeline. If it passes, we continue on. If any of the unit tests failed, what you'll see here is I checked fail if there are test failures. So what this will do is it'll actually stop my build. It'll send me an email saying, hey, something's wrong, come look at it. And then I'll be able to come in and see, okay, well, what did this failing unit test do? Lastly, I publish the artifact out. And this is the main database. This is only my production DDL. It doesn't include my test objects. And then at the end, I clean up the container and clean up the resource group. So we'll go ahead and kick one of these off. And then for those of you who haven't seen Azure DevOps before, so the pipelines piece of it is broken down into builds, releases, libraries, and then you have task groups and deployment groups. So builds are obviously what we've been looking at. Releases allow you to push your built artifacts out to wherever they're going to live. You can also do some of that, as you can see, through the build pipeline. Microsoft really wants you to separate those things out. Library is a library of packages that are for reuse or artifacts that you've built. And then task groups and deployment groups are reusable groups of, in the case of tasks, build tasks, in the case of deployment groups, deployment targets or servers that allow you to just drop those into your build or release and not have to recreate the wheel every time. And as this is building, I will warn you, this takes a few minutes. So I'll talk a little bit about the other pieces of Azure DevOps here while we're waiting for this to build. So overview, this is a dashboard view. It's great. Boards is where you would manage your work items. So if you think about the way TFS handled work items, or for example, if you've used Jira or Trello or something like that before, that's very similar to what you have in boards, obviously with some differences because all of the tools are different. Repos, this is where you're storing your source control. Now for this, I'm actually storing my source control externally to Azure DevOps off in GitHub, but I could store it either in a Git repository in DevOps or in an actual TFVC, Team Foundation version control, the old style of TFS code, also in DevOps. As far as repos, you're allowed to have as many Git repositories as you want. You're only allowed to have one TFVC repository. Test plans, this allows you to run tests through Azure DevOps that are not necessarily unit tests. So this could be like if you have a web application that needs to do some pretty heavy processing, you could do some load tests on that. I've used it in the past to simulate workload for an event-based system that we just needed to generate a bunch of events to see where the bottlenecks were. So it allows you some flexibility there. And then lastly, artifacts are the artifacts that we generate through our build. So as we're going here, so you'll notice the first few steps were reasonably quick. So it took us 35 seconds to build our main database, 24 seconds to build the tests. The warnings there, because I've targeted different different SQL Server versions for the main database and the database tests. So the main database is targeted at SQL Azure. The database tests are targeted at SQL Server 2017. The reason for that is our database tests have to utilize the CLR, so Azure is a no-go there. Container resource group, pretty quick. Creating the container is actually probably the slowest thing in the entire pipeline, and that's because we're bringing up an entire version of SQL Server 2017 during our build pipeline. And it's a new version, never had anything done to it, so it takes a minute. Now, as we're going on towards the deployment, and you can see as well, Azure DevOps, while we're going through, tells you everything that it's doing. There are some more verbose logging options, but really I found that for the most part, these are enough. And again, if we click into this guy, we can see, okay, this is our project, we cleaned it, we built it, and here's the output from our build, which was, oh look, there's some warnings because we're not really sure, refers to some temporary tables that it couldn't map out where they were coming from. All right, so we finished our main database deployment. And one of the nice things about the DAC pack I was talking about earlier is it tells us exactly what it's doing as it's deploying. So it tells us, okay, it's actually creating a database, creating schemas. Here it's creating tables and the constraints, and it's actually doing those in the right order, which is kind of nice. Does that automatically. Again, tables, some constraints, some foreign keys. It waits to create the foreign keys until the parent tables are there. And then it tells you how long it took. And you can see here that it's doing the same thing for our test. Great, so we run the tests. That was really quick. Get the results in the JUnit format, also very quick. Publish our artifact, and then we just do some cleanup, right? So that we're saving a bit of money. And at the end, once this is completely finished, So, and again, some of these Azure CLI commands do take a few minutes. There are some reasons for that, which I can address afterward if anybody's interested. Just be aware. All right, so we finished. We can come into our summary. So we had one build artifact published, which is our main database. and we see, oh, we have some tests, and they all passed. Okay, 2 total tests, 2 passed. If any had failed, it would tell us. If any had an uncertain outcome, they would tell us that as well. Get our pass percentage and how long it took, which is nice, and it took 56 milliseconds less than it did before. Now, if I wanted to deploy this, I could pop into my releases. And I could take that artifact, create release, and you see it populates in, and let's say I'll create that release. And that'll go off and deploy to my Azure SQL database in the background. All right, so what can we do to improve and extend this? So the biggest thing that I ran into while doing all of this is that having a dedicated build server would be incredibly helpful on a lot of levels. Number one, you can use whatever command line you choose to interact with Docker. You can run Docker on your build server so that all of this would run a lot faster. Because as you notice, the build is very slow using only the Azure native components. 6-7 minutes is a long time for a build to run. The other thing that I didn't really dive into here is how you handle data type changes or column name changes, or places where you might be destructive of data. So that's going to potentially involve a pre-deployment script and a post-deployment script, and have some sort of external knowledge of, do I need to run these scripts? So, a really good way to think about this would be like, okay, test to see whether the column is, whether it's been changed already. If it hasn't, I'll go ahead and run all of the logic. If it has, then I won't. And so didn't really talk about that at all. But it is something that is possible within the SQL Server database project, but also to automate within the build pipeline. Okay, there are some things that this doesn't solve for, which are important to talk about. So large-scale refactorings, this is going to be, anytime you have a large-scale refactoring in your database, something like this is going to probably slow you down more than it needs to. Now there are ways to automate, so you could run up all of your new tables, do a whole bunch of renaming, copy the data over, all within the build pipeline. I would suggest that's, because it's not meant to be a repeatable thing, that you may not want to do that. We didn't really cover load testing. You could probably have used tSQLt to do some load testing. I would suggest not doing that. I would suggest using a tool that's meant for that, such as the, what's the name of that? It'll come to me. We didn't really talk about a case where you need to specify a version in the database itself. This can get a little complex, especially if you have multiple developers working on the same branch, because who's responsible for doing the +1 to the version. And then I'd be interested to hear anything that from you guys that you think. All right, so that finishes up all of the content that I had to present. So now we'll take some time for questions.
All right, excellent. Thank you, Dan. So the first question that we got here today is how and where do we get tSQLt?
Right, so tSQLt is available, and if let me pop out of my slideshow, I'll head back to the slide where I talked about that. So tSQLt is available from tsqlt.org. Online, they have both the downloadable binary. They have some samples, and they have some really good tutorials that'll help get you started on unit testing.
All right. Oh, 1 second. Excuse me. And this one is more of a comment. Organizing by schema is not for everyone, especially when you have multiple schemas. You can change it, but be sure to include the schema name as part of the file name.
Yeah, so that's a great point, and this is not something that I've done in the past, and it's not to say that you shouldn't do it because, and I'll do a real quick example here once my Visual Studio cooperates with me. Yeah, I have 2 separate files that are referee.sql. This may get confusing. I have the benefit in this project of being the only person looking at this, but if you have more than one developer, that's probably a good practice to follow.
Yeah, I've done that as well, where I include the schema only because one of the systems I've worked on recently has about probably 20 to 30 different schemas. Another one, and somebody did ask this, and about if you can screenshot the detail of each of the build op steps as exporting the steps as the YAML is not easy to read / re-engineer to another environment. And in your scripts, do you have those pulled out, the YAML components?
I do have the YAML. I have it as all one YAML.
Okay.
But I can absolutely do some screenshots as well. Not a problem.
Okay. And then let's see, testing both load and functionality are the go fast for the CI/CD practice. They enable you to move to move the DB forward and ensure nothing is regressed, which is more of a comment than a question. And then let's see here, how do you get around cross database references in a DAC pack?
So you mean aside from avoiding that practice? So what you can do, this is actually something that I've run into in the past. It's a little bit complicated if you have databases that reference each other. But what you can do is, you can add a database reference. And so in this case, like I could add a reference to this other database that's in my solution. I can also add to a system database. So you can do it if you have a circular reference. Probably a DAC pack deployment is not going to be for you. I would suggest using a script deployment instead.
Yeah, part of the problem with those cross-database references is it gets trickier when you get start using functions across those references as well. If you ever run into it, highly avoid that. Highly. See, for databases that reference each other in a somebody had said for databases that reference each other in a circular fashion, generate DAC packs, put them in a file, and then reference that from a shared location, which makes sense. And then a specific question, and a specific SSDT question, have you had to handle DDL changes to CDC-enabled tables? If so, how did you handle that?
So I have not had to handle that case. And to be honest, I'm not even sure where to start with that one.
Right.
So I'll have to go back and do some research there.
Yeah, that could get tricky because that'd be tricky. And the last comment here is that Camille has a blog post that shows how to overcome circular references. And then looks like another comment that memory optimized and file stream is almost impossible with DAC pack. So it sounds like a lot of people have gone through some of these issues in the past. This is definitely it's definitely a challenging area within trying to implement. It looks like
Yeah,
the
I
last one
should,
we have here.
normally I say it. Oh, go ahead.
Oh, go ahead, because I had another question for you here.
Oh yeah, yeah. So normally I do give a good disclaimer up front that this isn't a panacea. There are some particular problems with DAC packs, particularly I sort of mentioned around if you're changing columns or using some of the more exotic functionality in SQL Server, it doesn't always get the order right, and then or it just kind of goes, I can't do it, especially if there's data in your database already.
Yeah. Yeah, and then another question that was here is for deploying any practices to push specific build versions to different environments without lots of extra screenshotting, like looking up a tag in VCS.
Yeah, so if we come back over here, I don't know if I can navigate to this quickly, but I'll try. So one of the things that we did here is, if I edit my build pipe or my deployment pipeline here, whenever you're ready there, Azure DevOps. One of the things that you can note is that, so I've got this artifact, and the artifact kind of knows where it came from. But also, I gave it this name. So, for example, in my build pipeline, and I'll come back to the releases and sort of talk about how we'd handle this. Mm-hmm. So in my build pipeline, when I publish the main database, I can name this artifact kind of whatever I want. There's some wildcards I can put in here as well. And then in my release, I can look for artifacts that look like that. And in fact, I can say latest from specific branch with tags, or specific at time of release creation, right? So, there's some options there to choose what you're grabbing. Like, does that answer the question out there?
I think so. And then the last question that we have here is how, you replied with that works. The last question that we have here is how do you overcome linked server references in a DAC pack?
You buy your security people a beer. So again, this is something that I've never tried to do. So the DAC pack is going to build, and it'll throw you some warnings. I'm guessing it would deploy just fine, but let me see if I can even, we'll do a little on the fly, can we do this? I think there might even be a template for linked server in here.
Yeah, and somebody did.
Yep, there it is.
Yeah. Yep.
Yeah, so you can create a linked server and this will get deployed with your DAC pack. Yeah, and it's just, okay, cool. Obviously, you need to know a little bit about how to handle these two stored procedures.
Right, and then a couple other people had commented that using a DAC pack use a DAC pack file for an external reference and use variables for the server and database names. And then there was another comment in there that mentioned to use synonyms for the linked servers. And I can attest that using the synonyms for the linked servers really helps to make it easier to manage.
Yep, I would agree with that, and that's a method that I've used in the past as well.
Yeah, the only problem I've run into when it comes to this, when you're trying to get a buildable SSDT project, is that sometimes you'll need to switch functions from being scalar to multi-line, as horrible and painful as that is, for it to be buildable. I've got a couple that I've had to actually deal with that. And then we got time for one last question. And then, so this last question is, can you build a server config script and include logins, roles, link servers, etc. as part of the deployment?
You absolutely can. And so there are a couple ways you can do that. So one, you can store the roles themselves, roles and logins themselves inside the project. You can also do it as part of a post-deploy script. So if we take a look at what these are, and obviously for roles and logins it would be a little different. But in this case, I'm just doing a merge into the table. Likewise, if you're doing a role, and so the roles I think you should probably store as static objects. For the logins, you can include them as, if this login doesn't exist, create it. If this login doesn't exist, create it, and just include that in a script file in your post-deploy. And I didn't talk about this, but the post-deploy script is a SQL command file that allows you to run a certain amount of, run your specified post-deploy SQL files, obviously after the main deployment is finished.
All right, great. And we have one last comment that Jamie Thompson had wrote some stuff up about a while back about handling that stuff in the post-deployment script as well. So, and he used variables to switch environments.
Yep. And you can also, in fact, using the DevOps build, you can inject the variable into the build as well. So there's some flexibility there.
Cool. All right. Well, that's everything we got here for today. Thanks, Dan, for presenting. Based upon the questions and the attendance today, this is obviously a hugely popular topic, and I'm sure a lot of people that were on here today are probably in the same boat I have. I've been in with trying to just get this to work with SQL Server, so this is extremely helpful. So thanks again for presenting.
Oh, you're welcome. Happy to do it.
All right, and thank you everyone who attended today's session. And with that, I'm going to close things out, and this session will be uploaded shortly to the meeting archive, and so you'll be able to rewatch it at that point. Thank you.